All right, so this question, iron nails placed in solutions of copper sulfate, magnesium chloride, lead nitrate, zinc chloride. In which solutions would you expect a coating of another metal to appear on the nail? Okay, so it's asking which of these ions are going to be reduced to their metal if an iron nail is placed in the solution. So it's saying if I've got copper sulfate, and the sulfate are just spectators, so we don't really need to think about them. So if I've got a beaker of copper ions and I pop a iron nail in it, will there be a reaction? Because if there is a reaction, metal will appear on the nail, because if there is a reaction, copper will be reduced to form copper metal and it will appear on the nail. So I need to think about, all right, which of these solutions will react with the iron nail? So I've got like different situations here. Iron nail, what's the next one? It is magnesium chloride, and the chloride ions are just spectators, so magnesium ions is what I'm considering. Lead ions with my iron nail, will that react? And will my zinc ions react with a iron nail? Okay, so we need to consider each of these separately by using my table here. So let's locate what we've got. So we've got iron nail and we've got copper ions, and this is what I'm considering first reaction here. Will there be a reaction? So where's my iron solid? It's here. So I'm going to highlight that reaction. Okay, and my copper ions. All right, what do I actually have present? I've got my copper metal and I've got my copper ions. So this is obviously the strongest reductant here. It's the only thing I have on this side that I've circled anyway, but it's the strongest reductant and the strongest oxidant here. Yep, cool. So I need to draw a line between these two species, and this line is downhill. So that tells me that a reaction will occur. Okay, because it's saying that the iron wants to give away its electrons way more than a copper metal would, because it's a stronger reductant. So this is going to want to give away its electrons, and copper is going to want to receive them. Okay, so what's happening is that copper will receive the electrons and iron will proceed in the backwards direction by giving away its electrons. So we write it out like that as well. So Fe2 plus 2 electrons. So this is the reaction that's occurring. Copper is picking up these 2 electrons that the iron is giving off. So there is a reaction, and the metal that will start to appear is the copper metal, because they're picking up the electrons that the iron really wants to give away. So yes. Okay, so in which solutions would you expect a coating of another nail to appear? So in which solutions? Well, definitely the first one. That's a big tick. Now we have to think about, all right, what about magnesium ions? So that's the one we're going to consider now. So I'll just rub all this out. And let's locate my magnesium ions on my table. So magnesium ions, yep, here. So let's highlight that whole equation. There we go. And I've got my iron metal here. So let's highlight all that equation. And we're going to draw a line between the two things that we actually have present, which is the iron metal in the nail and the magnesium ions in the solution. Okay, so that's an uphill line telling me no reaction will occur. And so that tells me that these magnesium ions aren't going to really want to accept electrons to become a magnesium metal. So that metal there is not going to appear, and so there won't be any appearance of that metal in this reaction because the reaction won't occur. The reason is because magnesium would much rather proceed in the backwards direction, okay, and give away its electrons because it's further down the table than the iron metal here. It's a stronger reductant. It would rather give away its electrons than receive them. Okay, so no reaction for that one. So that's a no. What about lead nitrate? So let's locate those. So lead ions is what we've got here now. So lead here, there. So let's highlight that whole equation. And I've got my iron nail still. Okay, let's draw a line between what we have here. And that's a downhill line, which means yes, a reaction will occur because iron compared to lead would rather give away its electrons, and the lead ions are happy to receive them. Okay, all right, so what happens in this reaction? So the lead will proceed in the forwards direction, and this reaction will proceed in the backwards direction. So the lead is going to be happy to pick up those electrons and become lead metal, which is what appears and what we see. And the iron is going to be happy to give away its electrons to that lead. Okay, so yes for that one. So that's a yes. Now zinc, let's look at zinc now. So let's find zinc ions here, and we've got my iron metal. Okay, so let's highlight those two equations and draw a line between what we have here. Now, this is an uphill line. No reaction will occur because zinc would much rather give away its electrons. It would much rather go in that direction, okay, compared to the iron in this case. So comparatively speaking, zinc would much rather give away its electrons than the iron here. So it's an uphill line, no reaction occurs. The zinc is not going to want to go in this direction because it would much rather, because it's a stronger reductant, than the iron metal here. It's a stronger reductant. It would much rather undergo oxidation because it's a stronger reductant. Okay, so it would much rather undergo oxidation, so it's not going to want to go this direction and undergo reduction. So uphill line, no reaction, no deposit of zinc in this case, that won't appear. And so that's a no for that one. So the answer is yes in the solutions of copper sulfate and lead nitrate.